In this video, we will be solving longest common subsequence coding challenge. It's lit code 1143. So the description is basically saying that we have two strings, so ABCD and ACE. And if we have those strings, the return value is 3. So let's look at this example. So the first string, A, B, C, D, E. And the second string is A, C, and E. What subsequent is that we are looking at each character. So let's say we have A here and A here as well. We can skip this B because the C is next. C is here as well, and the E is here. So we have 1, 2, 3 characters, and the return value is 3. Okay, so how to solve this is using dynamic programming. Yeah. So what we will have is 2D array. So ABCDE and ACE on this side. Cool. But this is not enough. We need another row and another column. And you will see why we need this in a moment. And we need to initialize those rows and columns to 0. So all the cells in this row are 0, and all the cells in this column are also 0. And what we'll be doing next is just going through each cell. Let's say that we're starting here. We see that character A is also character here. So this cell evaluates to 1 plus whatever is in this cell, right? Diagonally. 1 plus 0 is 1. Okay. If these two characters are not the same, then we pull the best or the highest value either from the top or from the left cell, right? So in this case, it's 1. So this guy here. Okay, so we just continue this. And now we're at second, so we pull this number here. It's bigger than 0. Continue, and now the C here is the same, right? And this cell becomes 1 plus whatever is from this cell here. So 1 plus 1 is 2. Okay, and we continue. So maximum value from 1 and 2 is 2. Maximum value again is this guy here. In the final row, here the cell is 1 because this 1 is bigger than 0. 1, and now we have 2, 2, and then E. We have the same character, so it's 1 plus whatever this character is. So 1 plus 2 is 3. And after we're done, we just return the final cell out. So we return 3. Cool. So let's talk about time-space complexity. For time, it's O n times n. For space, it's the same, O n times m. If you're brave enough, you can pause this video and try to implement it yourself. If not, let's do it together. Okay, so the first thing we'll do is create dp to the array. We will have helper function create to the array Cool. And now we need to just create outer and inner for loop. So let's do that. Start at 0. J. J++. Okay. So this inner loop is looping through each character from the text 2, and this guy here, oops, this guy here is basically looping each character from the text 1 string. Right. Now we need to just have, let's have a variable called column, which will be pointing to the current column, and it's j+1. Let's have a row variable. It will point to current row, which is i+1. Okay. So the first check is that if text1, the current character is the same as the character from the text2. If these are the same, then we need to update our cell. So dp row and column will be 1, so plus whatever it's in diagonally, right? So it's like when we talk about, so if we're in this cell here, the evaluation is 1 plus wherever is diagonally here. Okay. So it's row -1, column -1. Cool. If those characters are not the same, then we just take the max from the upper or the left cell. So for upper it's row -1, and for left is column -1. Cool. And after we are done, we just return the last cell, right? Text 1 or cool. The final thing we need to do is just implement the helper function. To D, it's rows and columns. We need to fill it with anything, and we will map through these elements. Just create new empty array with number of columns, and we will prefill this with 0 values. Okay. Cool. And the test pass. So if you have trouble with dynamic programming problems, the first thing you should do is use pen and paper. So like we did here. So write down examples and try to understand what is happening. And the second thing you should do is just solve a lot of DP problems. So yeah, that's it for today. Hope you have a great day. Until next time. Bye.